Isaac Newton is the co-inventor of the calculus, but he's also the founder of Newtonian physics. Why do we split Newton into two? It's the same guy. It's the same Newton. Welcome to the last part of the three-part series on how to teach math classically. This is the start of a conversation. We're going to be offering a year-long journey for educators to navigate what it means to teach math classically. One of the books I recommend is called The Mathematician's Lament by Paul Lockhart. Another one is called The Mathematician's Apology by G.H. Hardy. And then Journey Through Genius by William Dunham, which is the history of mathematics. Students need to learn the full context that gave rise to the concepts they learn in school. Let me know if you have any questions, thoughts, comments, objections. The full video can be found on YouTube. My name is Amos Tarfa. I'm a medical physicist and math and science curriculum writer, seeking to inspire the next generation of top mathematicians, scientists, engineers who know the history and philosophy of science, logic, and theology. People like Isaac Newton, James Clerk Maxwell, Michael Faraday. We want to re-inspire that generation. Enjoy the last third of this series. And again, the full video is on YouTube. Thanks for watching. Take care and have a blessed day. Math and the mathematical sciences should be taught together. If a school needs to have two teachers teach it, that's fine. But those two teachers need to be like, the students need to see those two teachers interacting and begin to realize that these two people are on the same team. It's not like, oh, that's my math teacher, that's my science teacher. They don't really talk. No. The integrative nature of the quadrivium, I think, is critical in part of what I'm getting at. But now let me bring it to life here. In that 1st to 12th grade program I described of the grammar, logic, and rhetoric, we also need every one of those years, the students are seeing the interaction between arithmetic and geometry and music and astronomy. Did you know that Leonhard Euler was actually alive at the time of George Frederick Handel? They were both contemporaries. That's crazy. When Handel's Messiah came out in 1741, Leonhard Euler was moving into full swing in mathematics. That's crazy. Now, I don't think they met. If you think otherwise, let me know in the chat. But I think that it's just interesting to think, how cool is it? How cool is it that we can basically show students the connection between all of these things? So we have arithmetic, geometry, music, and astronomy in the quadrivium, right? Johannes Kepler, Galileo Galilei, that's how they would have thought of math. Isaac Newton, Leonhard Euler, James Clerk Maxwell. Do you notice? So James Clerk Maxwell died in 1879, by the way. And when James Clerk Maxwell died, Albert Einstein was born in 1879. If you look at the history of mathematics and science after 1879, and especially into the 1900s and beyond, you will notice that there's a different kind of approach to science compared to people who lived before this time period. We need to go back to that type of thinking, because this idea of, you learn the math and science because you need to get a job, that's going to fall short in the AI revolution, because the AI tools are moving way quicker in learning certain basic principles that some students are trying to memorize to pass a test. But the goal of learning to pass a test is completely useless in the AI revolution. You should learn to master, and if you master, you will pass any test. Mastery should be the goal, but mastery that is connected to the bigger picture. Let's begin to land our plane. We need to study the ancient thinkers, Euclid, Archimedes, Pythagoras. We need to study geometry, logic, number theory, foundations of proof. We need to talk about Al-Khwarizmi, Fibonacci. We need to talk about algorithms and where did that name come from? Newton, Leibniz, Descartes, Euler. Calculus and analytical geometry, we need to talk about their work as well. They come in the early modern period. So we had the ancient world with Euclid, Archimedes, Pythagoras, and more. Eratosthenes, Tales of Miletus. Then we have the Middle Ages, Al-Khwarizmi, Fibonacci. Then we have early modern, and there's more people. I'm just giving a few highlights here. Newton, Leibniz, Euler, Descartes. Descartes influenced Newton's work, by the way. The Cartesian plane, our students need to make those connections. And then we need the modern age, Gauss, Alan Turing, some of the names that we know today, Terence Tao, and some of your students. Tell them that they are part of the story. They can make an impact. They need to stop thinking of math as just something I do to pass a class. There are, as we said, the logic phase. They will learn ancient medieval Middle Ages, early modern, and modern. And then there's a cycle 2 and a cycle 3. They're going to learn all of these things as they go through their work. There's a lot more that we can discuss. We need to encourage students that no summer breaks, no lower tracks. Every student is headed to calculus, because that's the other problem in American math education. If you told me, so listen to a conversation between a teacher and a student. And I'm sorry, I'm not calling out any teachers on this call. I know you're doing your best. A lot of you are doing your best, but these conversations come up a lot. Excuse me, Mr. Jones, why am I learning this? Well, when you get to calculus, you do it. Okay, child goes to another class. Mr. Jones said that when I get to calculus, I'll use polynomials, but I don't even want to do calculus. Oh, really? Well, then you don't need it. That child then goes back to class. Hello, Mr. Jones, when am I ever going to use this? Oh, when you get to calculus. But I'm not going to do calculus, Mr. Jones. Well, that's a good point. Well, just do it because it's on the state tests. We just took the most beautiful subject. Well, okay, let me take that back, because I know there's musicians and artists that are going to watch this. We take one of the most beautiful subjects ever, and we reduce it down to passing state tests. That's really sad. That's really sad. We need to rethink what we're doing in math education. It's not to pass the state test. It's because it's beautiful. But as human beings, we sometimes wrestle with just doing things, because they're beautiful. You need to tell me why I need to do it. So guess what? If I know I'm going to do calculus, then at least you have me to pay attention. So we need students to have continuity from counting to calculus without stopping, and they need to move at the pace of their mastery. These are things that we've built. You can reach out to us at countingthecalculus.org and we'll share that with you. Number 2, we need to make sure they learn how to struggle and work through hard things and get the support as they need the support, but they need to learn to fight through these difficult problems. Scaffolding can be a problem when it's done wrongly, and these are things we'll be discussing in the Teacher Training Institute. Number 3, we need the students to get the right mindset. Some of them say, I'm not a math person. We need to change that mindset. Math without history is a skeleton without a soul, is another way of thinking of it. Students need to learn their fractions and decimals and percents. And if we want, we can connect it to the AI concepts for those who want to go into AI research. Learning about fractions and ratios helps with probability, which helps in probability in machine learning models, right? So there's connections that can be made. And this is a research project I'm doing with one of my friends too. We're going to talk about all the different connections that can be made in pre-algebra connecting to other things. So what should schools do now? Let's land our plane. Number 1, we need to anchor every topic to a mathematician. Number 2, we need to read one primary document per term. Number 3, we need to eliminate summer math gaps. Number 4, we need to remove lower tracks completely, give students a chance to work hard and give them the scaffolding as they need it to keep pressing ahead. Everybody needs to do calculus. Number 5, we need to name the AI connection every lesson. So we need to name the AI connection every lesson if you are interested in bringing in that perspective. I don't think it's necessary for everybody, but there are some kids who are already thinking about, oh, I want to do something as an AI scientist. Well, show them how it's connected and they might care more. Or, you know what, not just name the AI connection every lesson, name connections to different fields that students might be interested in. If a child is gifted in anatomy and physiology and they know they want to become a surgeon, there's nothing wrong with showing them the connections between mathematics and science and being a surgeon. Let's help children have deep understanding and connections to what they're learning. And then we can use the trivium and the quadrivium to really help students learn well. We want to help 1 billion students to take calculus for fun as part of our goal. Mathematics is beautiful, and it happens to be the backbone of AI, but that's not why we do it. We do it simply because it's beautiful. Thanks for watching this video. I hope it was encouraging to you, and I hope we can begin to help more children to learn mathematics in a robust way in the AI revolution. Take care and have a blessed day.